Now we can start with the other presentation. As Tasso was mentioning, we have like 3 examples to show to you. I just want to say that in October 2017, there was the commission that opened a new call to improve modeling capability, okay? So it was an horizon call, and because of that, we have these 3 European projects. They are sister projects, and they decided to collaborate together, building a cluster, okay? So that is why we have all these 3 projects together today, okay? So we will start with the first one, which is BESTMAP, and we have with us Tomasz Václavic, if I'm correct. So I invite you on the floor. And he's from the University of Palaxy, right?
I can say it.
Okay.
Good morning, everybody. Thanks for having me. My name is Tomáš Václavík. I'm from the Palacký University in Olomouc in Czech Republic. But I'm here not to represent the university, but to represent the BESTMAP project. I'm here on behalf of the entire BESTMAP team because this was a really big collaboration. And first of all, I have to apologize Guy Ziv, who's the coordinator of the BESTMAP project, who is really sorry he cannot be here. So that's why me and here colleague James Bullock are taking over the presentations. So the BESTMAP project, just to get everybody on the same page, of course, is the Horizon 2020 project, part of the same call as the 3 sister projects here, part of the agri-clusters. And the whole idea, the whole goal of the project is to develop a modeling framework through which we can actually assess the impact of agricultural policies. We're not focusing on all kind of agricultural policies, but we're specifically focusing on the adoption of agri-environmental schemes or agri-environmental practices. We do this work in 5 case studies in Europe. So we have a case study in the UK, in the Humber region, in the Mulde region in Germany. One is in my home country in South Moravia, which is a traditional agricultural region. And then we also have Catalonia in Spain and Bačka region in Serbia. So basically 3 EU member states and 2 that are not yet or not in EU. And when I say we try to develop a modeling framework, we're basically adopting really kind of mixed method approach where we doing some social science work, doing interviews with farmers, getting information from farmers, and use those to parameterize agent-based models. And we link also these agent-based models with biophysical models of biodiversity and ecosystem services. So we're really focusing on the impact of the agro-environmental measures on biodiversity and ecosystem services. And we also look at different scenarios of the different levels of adoptions of these practices and how they impact the farmland. And ultimately, we're hoping that this will somehow improve the effectiveness of the future EU policies for agriculture. When I speak about agri-environmental practices or measures, I have to mention that this was actually one of the main tasks in our project, that what we mean by this is actually a different thing. It means different things in different countries or different case studies that we were working with. Typically, these are part of the agri-environment climate measures, this is the official term, which is the very important part of the second pillar of the Common Agricultural Policy. And we have examples such as here, the vegetation strip in the South Moravian case study, which may look like this. So buffer areas, vegetation strips, but also organic farming, the use of cover crops, fallow land, or things like extensive grassland maintenance. But these measures are implemented very differently in different countries. So in some countries, they are really part of these agri-environment climate measures, but some of them, like cover crops or fallow land, for example, in Czech Republic, they are not part of these measures, but they only are implemented as part of the ecological focus areas. And also in some countries, there's a huge variety of measures, tens of them, maybe even 100, and many of them are not used at all, only a small group are used. In some other countries, there are only a few types of measures, and it's a bit more easy to work with them. So actually harmonizing the data in a way that we can make some comparison or draw some comparison, some conclusions across the case studies, it was quite a big challenge of our project. But the main goal, as I mentioned, was developing this methodological framework that we can use to assess the impact of these policies. And it was all based on a premise that the traditional models that are assessing the policy impact, these policy impact assessment models, they are limited because of two main reasons. One of them is that they're really mostly based on a relatively broad economic or socio-economic indicators. And also they, of course, inherently they ignore the complexity of the farmers' decision-making. And that's why this is what we try to do in our project. We basically try to look in the head of the farmer and try to disentangle what is the motivation, the rationale that drives the decisions of the farmers, and how these decisions actually affect the farmland on which they operate, and vice versa, how the different environmental and farm structural characteristics, how they affect the decisions that the farmers make. And so if we really simplify all the complex work we try to do in BESTMAP, we can simplify it into three kind of conceptual steps. The first one is that we acknowledge that the European rural landscape is really managed at the farm business level. So the farmers are deciding what to do. But because we cannot model each farmer individually, we try to simplify the system, and we came up with a typology of farms, which we call farming system archetypes. So basically types of farms that behave similarly in terms of their response to policy change. The second step is acknowledging that farmers' decisions, although in the typical models we assume that they are economically rational and they decide in an economic rational way, they don't in reality always do that. And so that's why we try to use agent-based models to actually capture these behavioral and social aspects of their decision-making. And lastly, because all these things are happening in a certain geographical context with different environmental and ecological characteristics, we then try to apply biophysical models for biodiversity and ecosystem services, and we try to assess what is the impact of the different agri-environmental scheme adoption scenarios on biodiversity and ecosystem services. And so what I'll try to do, I'll try to show you some examples of what we came up with based on these three, let's say, methodological steps. So first, as I said, we based our work on the assumption that farms that are similar in certain characteristics, they will respond similarly to policy change. They will, for example, adopt agri-environmental schemes in a similar way. And so we came up with a simple a typology of farms that we used basically based on two simple criteria. One is farm specialization. So based on a simplified FADN methodology, we came up with 5 categories of farm specializations. So we have P1 farms that are focusing on general cropping, farms focusing on horticulture, permanent crops, grazing, livestock, and pastures, and then farms that are mixed in terms of their farm specialization. And the same thing for economic farm size, based on, again, specific methodology. We basically, for each farm in our case studies, we're able to estimate what is their economic size, and we just classify them into several categories from large to very small farms. And we were able to do that basically for each individual farm in our case studies because of the access we got to this LPIS data, this land parcel identification system data that has information on each individual field that belong or that's being managed by each individual farm in the case study, and we know what crops they grow on them, what agri-environmental measures they apply, and many other information. And so that's why we were able to create this typology. And if we combine these categories of farm specialization and economic farm size, then we get to these 20 categories of what we call farm system archetypes. And this is just an example how this mapping and this categorization can look like in South Moravia, in the Czech case study that I managed. And here in the colors, you can see the different colors show the different farm specializations, from general cropping to mixed farms, and the different hues basically show you the economic size. So the dark ones are the big farms, the light ones are the small farms. And just one thing that it's very typical here for Czech Republic, but also for our case study in Eastern Germany, the former Eastern Germany, is that the majority of the land here, more than 80% of the land, and you can see it on the graph here as well, it's really managed by these large agribusinesses that are focusing on general cropping. Right, so and it's actually in this case study, there's about more than 1,000 farms. 80% of the farm is managed by about a dozen large agribusinesses. When we look at the number of farms, not in terms of the area, but the number of farms, then the picture is quite different. You still see that the large agribusinesses, there's quite a lot of them, but actually it's not the most frequent category. Here, in this case, farms focusing on permanent crops, and especially on grazing, livestock and forage production. There's many more farms like that, and the majority of them are really small. So farms that are this below 2,000 euro economic size category, right? So the picture in terms of what land they manage and how many farms there are, it's quite different. And then we use this farm system archetype typology for very different purposes. So one of the things that we've done was that we looked at how these different categories of farms, how they actually adopt, what is their adoption rates of the different agri-environmental practices that we looked at. And these are some of the results. So in this case, you can see on the first graph, on the x-axis, the different types, the groups of agri-environmental practices that we're looking at. So cover crops, fallow, organic farming, grassland maintenance, vegetation buffers. And with the different colors, you can see basically the distribution of the type of farms that are adopting these practices. The picture is quite complex. There are, of course, differences between the case studies, but the general pattern is surprisingly holding quite well. It's quite consistent. And one thing that we can draw from this, it's quite typical that some types of agri-environmental schemes are adopted only by certain types of farms. And there was also a huge difference between the size of the farms. So in general, we can say that the large farms, especially the ones focusing on general cropping and on the grazing livestock, they are more likely to adopt agri-environmental practices than the small farms. And also, when they do so, they adopt much wider range, they have much wider portfolio of the measures that they adopt than the small farms. And this is also quite visible if we look at the non-adoption. So we look at all the farms that do not adopt any agri-environmental measures, and there was always more than half of them in each case study. Then you can see, in this case, you can see the light colors, which means the light colors means these are the farms of the small economic size. So the non-adopters, the majority of them are really the small farms. And again, we can then discuss what are the reasons for that, and I'll get to it because we got that information from the interviews we got from farmers. But yeah, as I said, in very general terms, the large farms are more likely to adopt the measures, and a larger or wider portfolio of small farms do the opposite. If they actually adopt something, they're only focusing on one or two specific agri-environmental measures. And so this kind of shows that that there's a potential for a typology like that, which is very simple typology, that can be used as a kind of a framework to infer some key patterns about the adoption of agri-environmental schemes. So that was the first step. In the second step, what we tried to do is do the social science work and try to get a lot of information from farmers. We ran 2 interview campaigns with farmers in all the case studies. First was really direct personal interviews with farmers, which was a bit hampered by the COVID because we started with it and then the COVID came, so we had to switch to phone interviews. So maybe the size of the sample of farmers that we interviewed wasn't as big as we would like to, but still we interviewed over 150 farmers, and then we followed up with an online questionnaire where we tried to get information from farmers not only about like what motivates them, what are the reasons for implementing these agro-environmental practices, but we also provided them with a discrete choice experiment. So basically, we gave them hypothetical contracts with different parameters of the contracts for the agro-environmental measures, and they can choose what they would prefer. And based on this, we can then use that information and to feed it into an agent-based model, which would then help us to model like what are really the main reasons, the main parameters of these agro-environmental measures that drive the uptake of them by farmers. And some of the kind of the main lessons that we learned from this exercise was that, well, it was quite clear, and again, consistently across all case studies, that the main motivation for farmers is economic. It's the environmental reasons is always secondary. The economic compensation is the main motivation, and they basically perceive this as some form of income diversification. So even though these measures are meant as a compensation for income forgone, right? So they cannot plant crop, the same way as they would want to. They have to change their practices. They should be compensated for that lost income, but for them, they really see it more as it's an additional income. If my crop production doesn't go well one year in some areas, at least I have some additional income from other places. The farmers also had a tendency to really put or adopt only those schemes that are somehow were fitting with their established farming practices. So very often they were telling us, we're doing these measures only because we would be probably doing them anyway, but now I can get also some additional source of income for them, right? So that was a main insight. They also had a tendency to put the measures not on places where it would, from our ecological point of view, it would make most sense, but they had a tendency to put them on a marginalized or unproductive land. And some of the other aspects that affected the rate of adoption by these measures was some other parameters of the contract. So, for example, the duration of the contract had or the flexibility of the contract had a big effect. The farmers were really asking for shorter contracts with more flexible conditions, because very often they would say, we would like to maybe apply for some agro-environmental measures, but for example, the area requirements or maybe the deadlines where we have to, for example, do a grazing or mowing of the area, it's strictly defined in the conditions of the contract, and we often cannot meet the conditions because every year is different, the weather is different, and for us it's just too much risk that we don't meet the conditions and then we get fined for them. So the more flexibility and shorter contracts is something that they were asking for. And especially for the small farmers, they perceived the bureaucracy as too much of a burden to actually participate in these programs. And this is the reason why, when I was showing the graphs before, right, the non-adoption, why it's mostly the small farms that are not adopting anything. Well, that's because they don't have the manpower, they don't have the capacity to actually do all the paperwork and apply for these measures, while the large farms, they do have administrative capacity to do so. So that's why there was a big difference. And then all this information, as I mentioned, was fed also into these agent-based models that we developed separately for each of the case study, and we were able to model the effect of different scenarios. So we were changing the different parameters of the contracts and looking at how it affects the adoption rates. And basically, really, the agent-based models mimicked quite well what we learned from the farmers directly. So, for example, this is an example of adoption rates in Catalonia, for different types of agri-environmental practices, and the different colors show the different scenarios. So the yellow one is the status quo, and then we have scenarios where we have shorter contracts, we have more advisory support, we have lower bureaucracy, we have higher payments. And what we learned from it is that, yeah, the two parameters that has the largest effect is, of course, increased compensation, so higher payment levels, but also shorter contract duration, so more shorter and more flexible contracts. They had a huge effect. But there's lots of other nuances that we can go into, and we have quite a few nice publications that came out of it, and so you can refer to them if you're interested. And in the third step, what we've done is then we looked at these different scenarios, and we modeled and assessed the effect of the adoption of agri-environmental measures on biodiversity and 3 selected ecosystem services. So for biodiversity, we looked at impact of these practices on selected taxonomic groups using species distribution models. We also looked at effect on food and fodder production, so basically what's the impact on production area of specific crops. We also looked at water quality in terms of what is the nutrient and sediment retention, so how much phosphorus and nitrogen is being retained in the agricultural landscape and how much of it is being flushed to water streams. And then we also looked at carbon sequestration. So again, how much of the carbon from the atmosphere is being sequestered in the organic matter in the soils. And again, we have all these models documented. They're open source, so the code is available. They can be applied to other regions. I just show you maybe some examples that we have. So again, this is an example from Czechia, from the South Moravian case study, where we, again, based on the LPIS data and based on the types of crops and the types of management on each field in the case study, we're able to model what's their, for example, relative difference in soil organic carbon between a status quo and between one extreme scenario where we simulated what would happen if we just remove all the all the agri-environmental measures from the farmland, right? So if there were no measures, and you can see in some areas it's gain, and some it's loss, but we can show it like this also for the different types of farms. And in this case, the box plots, the green ones is the current adoption of these agri-environmental practices, and the pink ones are the ones that simulating that we have no agri-environmental measures at all. And you can see in all cases, the agri-environmental measures, they do have some positive impact, but actually the impact is quite marginal. It's very similar. The measures, the level of their current implementation is just too low to actually make much of an impact. One example in terms of modeling biodiversity, we of course could not look at biodiversity as a whole, but we looked at few indicator taxonomic groups. So farmland birds are very good indicator groups of biodiversity in the farmland. So here's an example from Germany where we looked at 15 farmland birds. We accounted for, in our models, for all types of environmental characteristics, topography, the type of land cover, heterogeneity of crops, and we've done a species distribution models at a very high resolution, at 20-meter resolution. And basically, we accounted for the area and the spatial, the composition and configuration of these agri-environmental measures in 3 different spatial scales around the occurrence data of the species that we were actually modeling. So we had scales of 200 meters, 500 meters, and 1 kilometer buffers around the locations where we had confirmed occurrence data points for each of the 15 bird species. And then we used these multi-scale ensemble species distribution models. these are just modeling approach, which is combining statistical parametric models with these machine learning algorithms, which today you would call AI, artificial intelligence, which just looks at all kind of mathematical functions that fits the data. And what we came up with, this is a very complex graph, but you don't have to care about everything. We only want to look at these variables that represent these agri-environmental schemes. This basically shows that we accounted for all the environmental variables, and once we filter out their effect, now we can look at the effect of agri-environmental schemes. And what we would like to see is that we would like to see this kind of a funnel shape. So with increasing area of this agri-environmental scheme, it's basically the habitat suitability for the species is actually growing, right? So here on the y-axis, you have the different species that we were actually looking at. And so it's quite nice that we found that for most of the agri-environmental practices, we found positive effects, especially for buffer areas, for cover crops, for extensive grassland. So you see here for Eurasian skylark, the increasing area of buffer strips or vegetation strip, it's really increasing the habitat suitability. So the effect is positive. So that's a great thing. However, the effect was not always positive for all species and not always the same at each spatial scale. And what that means that, for example, interesting aspect was that for organic management, for some species, and there were quite few of them, we actually get slightly negative effects. And again, we were discussing this also with ornithologists, and one of the reasons why we may find this negative effect is that, well, we would assume that in organic farming you use less agrochemicals, so there may be more, insect resources as a food resource for the birds. But by using less agrochemicals, there may be needed more physical intervention in the crop, in the field. And if the physical intervention meets, is happening at the time when the birds are breeding, then it's a disturbance, and you're actually having a negative effect on the birds, right? So again, this is just showing that the nuance is quite complex. And of course, there was also an effect of spatial scale, but we don't have to get into the details. And then what we can do with this, well, we can model different scenarios of agri-environmental scheme adoption. So we can have a look at, and this is for the Mulde region in Germany, the current scenario, the current adoption of the agri-environmental schemes. Then we can have a scheme that's simulating that what would happen if you remove all the measures in the study area. And then we have something like a conservation-oriented scenario. So the one where the federal state of Saxony, they have some conservation goals. And so based on their goals, we just distributed the simulated additional increase in agri-environmental measures in the study area. And what we would assume is that we get results like this. So this is a result for red-backed shrike, one of the typical farmland bird. We would see that the conservation scenario increases the habitat suitability, and the simulated no agri-environmental measures would decrease the habitat suitability. Right? And for this bird, it works actually quite well. But if you look at the other birds, it's not exactly the same. So for 9 out of the 15 species, there was a positive effect. For 6 of them, it was a bit more nuanced. But maybe the most important thing that we want to here look at is if you compare the green and blue, that means the status quo, the current area of agri-environmental schemes, with the ones that simulating no or complete removal of agri-environmental schemes, you see that very often these green and blue boxes, they don't actually change much at all. The difference is very, very marginal. And they're just suggesting that actually the effect of the agri-environmental measures, at the level that we have them now, their effect, although it's positive effect for the habitat suitability, their effect is very, very small, right?
Sorry, Thomas, if you can just be quicker because we are running out of time.
Yeah, okay, so this is basically one of my last slides. So we are saying, okay, the effect is positive, but at the current level of adoption, the measures are not really doing much difference for the biodiversity, and we definitely can help with that if we do maybe better spatial targeting. and having a very kind of diversified set of measures that would offer also a varied mix of different habitat types and different food resources for the birds. And again, there are some publications out of it, and basically the same type of results we get if we look at all the other ecosystem services. So here we have the ecosystem services for different case studies, and this is the biodiversity and the four ecosystem services. The difference between the current scenario and the one that simulates no presence of agricultural measures, the difference is always quite small. So we're basically saying, well, if we have these measures on 2 or 3% of agricultural land, well, it's better than nothing, but the current level of implementation is just way too low to make much of a difference. And yeah, these are some of the main insights. We try to disseminate the project findings through different ways. We have an online dashboard that's now operational where you can visualize some of the data, look at some of the maps. And we also created policy briefs in the local languages and also in English, and many of them are available here. And this is just an example of a policy brief that we use for like our ministries in Czech Republic, but we have them for all the case studies. So if you're interested, we are happy to distribute this to you. And a lot of the information that I've just mentioned are nicely summarized in these policy notes. Thank you.
Thank you very much. So I think, Thomas, is the time that the people can make questions if you want. I just want to break the ice with a quick question. It's about data. Tassos in the beginning was mentioning the importance of data, and I know that in BESTMAP there were several issues about that data. And so I wanted to, if you can quickly explain what happened and how this, you think, was affecting the result of our work.
Okay, so with, well, we do mostly modeling work, and like modelers always say, you know, garbage in, garbage out. If we don't have a good data, no matter how sophisticated methods we use, we're not going to get good results. And so we are really relying on data. We had many issues with the data sets. One was, of course, data sharing. Well, first of all, for some of our upscaling work, we are using FADN data. We were promised from the very beginning that we will be able to do it, but it actually took us 2.5 years to receive the FADN data. We asked for them, then we were told to like, okay, we have to clarify which variables exactly you want because we cannot provide you the full data set. We narrowed it down several times, but it was really a lot of effort to actually get hold of the data. A similar thing, it was with this EAX-LPIS, this land parcel identification systems that we requested for each of our case studies. In some places, it was quite not that difficult. Like in Czech Republic, our ministry was happy to provide the data, and we were also able to share the data within our project. But in other cases, like in the case of the UK or in the case of Germany, we were provided data, but we are not allowed to share it outside of the institute who got the license. So even though we thought we do the modeling more kind of in a centralized way, we then had to do the modeling separately in each of the case study. We had to completely restructure the way the project was supposed to work, and we had to find modelers and people responsible for each case study because we are not even allowed to share the data just within our project, right? So that was one issue with the data sharing. Of course, another aspect that we were discussing yesterday is the homogeneity of the data. So even with this LPIS data, the way how the system of the collection of the data from farmers, how it's implemented in each member state, it's different. So the data structure, the type of variables that's being collected, and the way how you can access the data, it varies hugely. And so just homogenize the data and put them in a form where we can run some analysis and then compare the results across case studies. It was also much bigger effort than we originally envisioned.
Yeah, and also there was COVID, so the data collection was even harder.
COVID didn't help.
Okay, so now the floor, if you want to, there should be someone, Oscar, with a microphone.
It's coming.
Someone. So he was the first one. If you could please introduce yourself and just mention the organization you are representing.
Kurt Geisert, I'm one of the guides in the House of European History. We have many demonstrations of farmers in many member states. For example, we had demonstrations in Brussels in context with the last European summit. The European Commission reacted quickly. Are you optimistic, perhaps also the first speaker, are you optimistic that this can be a model for a number of member states? In Germany, we do not have this impression. Thank you.
It was more of a comment.
Yeah, it was more a comment instead of a question. Tassos.
Well, what do you say? I'm still in the 2-year cool-off period. Anyway, I think one has to wait for the European elections, for which I'm not at all optimistic, to see how we move further. But because we have always moved with crisis, I think at a certain point of time we will realize that instead of polarizing the debate, it's actually by using examples like that you can have a much more interesting discussion that focuses on what you can do to move things forward, allowing more choice to farmers, but also making sure that we don't go backwards.
Hi, Thomas. This is Ignacio Perez from the GRC. I've been in the advisory board of this project and been discussing many times with Guy, and I have to congratulate you because it's really nice what you guys came up with. So it was a very nice presentation. I have a couple of questions, maybe 3. First of all, what is the economic dimension? So I'm missing a step at the end, no? So I'm missing, like, you've been looking at AAPs, agri-environmental schemes. You've been looking at how this can impact. Have you thought about the cost of these policies and the benefits that those policies could bring in terms of don't worry. I mean, I'm just pulling some things out there that might be useful. The benefits that this could bring in terms of biodiversity. No. The second one is, I know you guys had a work package on upscaling, so we are pretty much interested in kind of pan-European analysis. So, what are your thoughts? What are your conclusions about upscaling, like very detailed information from regions to Europe? And the last question is easy. You guys have some ideas about moving forward with another project?
Okay, thanks a lot. I'll first address your second question, which is about upscaling. And with that, I will refer to James, who will be actually covering it in detail in his presentation, because this was actually quite a big task in the project and a quite challenging task to somehow come up with a way how we can transfer the results from our case studies to kind of pan-European level, and we hopefully came up with a nice methodology to do so. In terms of the economic side, I'm an ecologist by training, so I'm not really feeling qualified to answer this question. But of course, there's always, so in general terms, always a balance between, horizontal policies that are applied kind of widely, and then because of that, their administrative costs are much lower than if we have policies that are very specialized, very much targeted, kind of targeted locally, but also thematically. And I think we just need to find some balance between those. And I think this is also one direction to which we're hinting with this work. So for example, with this farm typology, the farm system archetype, it is one way how to actually look at different groups of farms, and we can potentially target these farms differently. So for example, different types of farms, maybe we can use this typology as some eligibility criteria for applying for certain type of measures, or the conditions of the measures can be tailored more specifically to the types of farms. And I think this would be a good way. Of course, it would be more complicated in terms of the administrative implementation, but also I think it would be a good balance between what it can bring and what the costs would be. And the same thing is about, let's say, more spatial targeting. One of the things that's clearly coming out of our work is that, well, we not only need to increase the total extent or the area or increase the uptake of these measures, but they're not often put in places where it makes most sense, where it would really can maximize the biodiversity and ecosystem service effects. And so if we can do a better spatial targeting, so I don't know, putting vegetation buffers in the places where it most increases the functional connectivity of the landscape, which is really important for the biodiversity. This way we can, with just little more cost, we can much more optimize, or let's say maximize the biodiversity effect of these measures.
Okay, well, if you can quickly, maybe we can address both.
Good morning, I'm Gonzalo González from the European Commission, the Environment. Two brief questions. First one, going back to the data, it wasn't clear to me, those data you show in biodiversity, are they based, for example, this data with the farmland birds, are they based in field surveys, or this is just a theoretical exercise? And second, the main conclusion was that it was necessary to increase the surface of the current measures that there are in place. But did you explore if there were any other measures that could be more efficient than the ones we have in place now?
Okay, so in terms of data, so for the biodiversity data, we were using really point occurrence points of each of the species, and we use the data, we get them from different databases in each case study. So in Czech Republic, we have this national survey database where it's a compilation of different sources, and this is actually freely available, so you can use it's a part of a monitoring system. In some other countries, like in Germany, we use this Saxonian federal database of species data. So we really draw from different sources in different case studies. The issue with that is that actually this Horizon 2020 call is prescribing us to use only existing data sets. And again, this is something we were discussing yesterday at dinner. Us, because I'm ecologist, many of us are ecologists, when we present the results from the biodiversity models at Ecology Conference, they always tell us, well, but you use these existing databases, and it's not like you collected the data that are exactly tailored for this purpose. The data have all kinds of biases, so maybe, it would be ideal if you can use data with a specific sampling design that's really much better fit for the purpose. And that's why I would really like to see in the future calls in Horizon Europe that, especially for biodiversity data, because we still have only anecdotal evidence of how these types of measures are affecting biodiversity and ecosystem services. It would be great if we can really, even though it might be a bit more costly, it would be great if we can really collect data specifically for the purpose of assessing the effect of these measures. So it was one question, and what was the other? Did you explore further? Yeah. No, because we were really working on modeling, so we were really just using observation data, right? So we are not simulating an effect of something that's not existing at the moment. So only those that were existing. And again, we were grouping them because, as I said, the implementation in different case studies was different. So we are grouping them into groups of agro-environmental practices that were homogeneous enough so they can be compared between the case studies.
So we have the very last question.
Yeah, thank you very much, Antonia Lütken, also European Commission DG Agri. So thanks for the great presentation. It was really, really interesting. My question would also be on the modeling on the time frame, because in particular, when you look at the modeling without any agro-environmental schemes on birds, I mean, biodiversity is not reacting from one day to the other. So in particular for that one, if we don't have anything, how would bird populations develop on the long run? Now you saw very little differences. Would that be the same on the long run? I mean, now we have, of course, to take into account that also agro-environmental schemes may not last forever. But the time frame, of course, for biodiversity is very important here. Thanks a lot.
Yeah. Thank you very much. From an ecologist point of view, this is a really, really crucial question. And that's something that, again, we did not address directly. We were working, in this case, with habitat suitability. So basically, the suitability of an environment to support population of these birds. But we did not have data on population fluctuation, population development of these species populations. And also, of course, there is a time lag. So whenever a certain measure is implemented, it doesn't mean that it's changing, the quality of the habitat immediately. There will be always some delay in the biodiversity to react to that. So this would be, again, another kind of a plea for we need to get or be allowed to actually collect better data so we can also actually address this temporal aspect, because in this case we were just matching the species occurrence, the time, the year when it was recorded with the agri-environmental measures that were implemented in the same time, right? And we did it over a short kind of a window of time, but we could not look at the temporal dynamics of the system, and it would be really nice to address it in the future research.
Thank you very much, Thomas.